So, yep, I think I'm audible to everyone. So, hello everyone. I hope you all are doing great, and thanks for supporting our community. So, we have developed a WhatsApp group of more than 300 followers on it. So, we are constantly updating the current job openings on the CAD and CAE and also on the LinkedIn. So, we have a lot of people who are supporting to our community. So, well, so taking these all into account, so we are excited to announce the second session on the webinar on the structural analysis, NVH, crash and durability. Well, so I'll be taking you through from the scratch. So if a person is beginner, that guy also can learn simulation and he can start working on any of the field like the NVH, durability and crash in future. Yeah. So accordingly, I have customized the session. So in the previous session, I had covered the basics requirement and what exactly people can do, how they can start their career, what and all the options are available for their career. So I had just gone through that. If you haven't referred that video, I kindly suggest you to go to that video and refer it once and then go for the second session. Okay. Well, let's get started with the session. So before that, again, I would like to introduce ourselves. So we are Technocraft Academy. So we are the training providers for most of the fields, like starting with the computer applications, spoken English, CAD, CAM, CAE, considering all the softwares, like starting from the SolidWorks, AnyGraphics, Creo, Fusion 360. So most of the CAD tools we teach and also train the industrial as well as the corporate employees and also the colleges. So also we provide the customized trainings. Okay. Along with this, we have the data analytics on also the full stack development course. Okay, so these courses we provide the training as well as 100% placement guaranteed. Also, the people who are going to join our institute, so we are assuring that we are going to provide them 100% placement, and we'll also train them on the resume building and the interview preparation skills, and also the soft skills needed for them, and also the communication skills, which is very important for them. So these are all the things we are doing from the Technocraft Academy. Well, so that's all about ourselves. So what I'll do is I'll take you through the basics of the simulation. Okay. So I would like to just ask you a question in short. Let's say if you're a CAD guy or you're a fresher or you're a student. So if you don't know anything about simulation, how do we start? Is the question, right? So for that, you need to refer the basics of simulation, fundamentals, SOM, DOM, everything. But which software I should choose at the beginning. But if you don't know how to set up the boundary conditions and run the simple basic simulation, assume then normal stress analysis or the normal model analysis or simple buckling or a fatigue analysis. How do we run it? So to answer that, I would recommend each and every one, if you're a fresher or if you're from the CAD domain and if you want to learn simulation, start with the basic CAD tool itself. Let's consider the SolidWorks. So in the SolidWorks, we have the tools for the simulation. So we'll take that into account and we'll try to learn how exactly the simulation is going to work. Yeah. Let me just open the SolidWorks software for you guys. So we can just start taking this basic example and learn how exactly we could do the basic structural analysis on it. Okay. Well, so I'll just open the part modeling. So I'll simply, what I'll do is I'll draw a rough part. Okay. Consider what I'll do is I'll just start with the center circle. Okay. Let's assume this is the sketch. We'll take it as 75 tab, and then here I would like to consider it as 200 is fine for me. Yeah. So this is the sketch, and I'd like to also have the circle at the center. And I would like to have one more here. Let us see how these are going to impact. Okay. If you want to again define the dimension for this, I'll assign 35 for this, and let's consider this as a 16. Okay. Or 15 is fine. If you want, you can even define the dimension for making it as standard. Let's say if you want to do this analysis again and cross verify everything, so you should need the dimensions, right? So consider these as a reference for us. So I'll just make it vertical for this one. So hold the control and just select these 2 points and make it horizontal so that it is fully defined now. Yeah. the sketch is ready. You can exit the workbench. Now I'll simply create a rough sketch out of it. So you can simply drag it like this. As I'm only concerned about the thickness of it, I would like to keep it as least as possible. As 10 is fine, so you can just rebuild it. So this is the model which I'm going to consider. I'll just switch to the white plain background. Let's assume this is the model for the simulation. Okay, so let's assume, so if you are completely new to the simulation background, what you can do is, you already know about the SolidWorks. If you even don't know about this, please refer my CAD webinar, so you'll get to know how you can work on the SolidWorks also. Just to have a basic knowledge on how to create the models and run the basic simulations is great for you. If you're working with the medium scale industries and the small scale industries, this is also recommended. And if you want to get into the automotive industries, then HyperMesh, Ansys, Bacchus, okay, these all are preferable. So we'll also catch them later on, but let's concentrate on the syllabus. So first thing you need to do is you need to activate the simulation add-on. So for that, you can just click on this icon here, the drop down, use the add-on. Okay, here if you are using the package of SolidWorks Premium, simulation also included in that simulation standard, you can use it. Okay, so currently I'm using means I have the premium version, so I have the simulation standard and simulation professional and premium also included in it. So I'm having the premium version, so I'll be having all the access here. So once you activate the add-on, so you can have the study background. You could say simulation is activated for you, and even analysis preparation is also there, so that you can use all the tools to split or make some modifications, apply the fillets and expand the surface. You can do it. In short, the model build activities, you can do it in simulation. Now what you can do is you can switch to the simulation tab here. There's a new study, right? In the drop down you could see we have the new study and simulation advisor. If you click on this, this tool will guide you how to set up the boundary conditions also. Let's see that later. First I'll click on the new study. Okay, could see once I do that, automatically it has given me the property manager where I have the simulation tab open. I can just define it as a test version for me. Okay, what analysis you are doing. Okay, you could see a lot of analysis out there, the static, the frequency, we have the thermal, buckling, fatigue, nonlinear. So I have most of the analysis included in it. Okay, as I'm using the simulation premium version. So let's consider the basic thing what we want to do on this particular session is the static analysis on this. So I'll just select the static here. Okay, so I'll simply click on okay. So automatically the tab is created, you could see now. So you can even switch like this if you want. The static tab is there, you can set up the boundary conditions. In the simulation, you need to know the steps. First thing is you need to have the model, correct? So once you have the model, you need to make sure that model should be preferable for the analysis. Let's say if you want to run a basic structural analysis, try to avoid all the fillets. Let's assume here in this model you might be having some of the fillets like this. Okay, so in this case, so what exactly solver will do is it will try to apply the more finer mesh on this one. So anyway, this particular mesh is not exactly needed for, or this region is not at all necessary for our simulation. So for that, if you think if these fillets are not impacting your simulation results, you can simply suppress it to save the time. Okay, the computational time will save. For that, what you can do is you can simply suppress them by using the suppress tool. It's quite simple. Okay, if you want to check here, you can even cross verify here. You can unsuppress this, so you can even come to this and here suppress the features. So this is the model build activities, we call it. Okay, once you are sure that your model is ready, okay, what you can do is you apply the material for this. So in the material, you could see right click. If you go here, you have all the standard materials available. Or if you want to explore all the materials, you can simply right click again, select this apply or edit material. Assume you have the tab here also. If I just select this, it will open the material tab. Okay, so this is the alloy steel. You could see the properties. The most important is the elastic modulus, the Poisson's ratio, and density. Density is just to cross verify the mass of this one here at the moment. But for the structural analysis, the Poisson's ratio, yield strength, and the Young's modulus are important. Okay, Okay, very important. So now let's assume I would like to take this as a standard material, alloy steel. You can simply click on it and apply. Okay, could see the Inks modulus is this value. If you want to change the SI unit system to megapascal, you can easily understand. Okay, it is 210. Okay, simple, megapascal. Fine. So once you apply the material, so the next step is to apply the connections if we have it. Okay, might be having the contacts. Okay, there are a lot of options to define. So in the next session, if I take the assemblies into account, so that time I'll show you how you can just assign the contacts here. Okay, so just forget about the contacts now. That's a vast topic you need to explore. Now, if you don't have any contacts into model, assume your model is very simple, so you have a simple model. So for that, what you can do is you can neglect the contacts and you need to go ahead with the boundary conditions. Let's say assume you need to apply the fixtures and the loads. So now next tab is to apply the fixtures. Okay, you can simply right click here on this. So you have the fixture advisor. If you take it, it will automatically guide you what exactly you need to do, or else you can directly select the all the fixtures are available. Okay, the foundation bolt, the bearing fixtures, we have the hinge also. Okay, even the slider or roller also available, but at the moment I would like to go ahead with the fix. At the particular face I would like to fix, so I'll select the fixed geometry. Okay, now you could see it also shows all the things. You can even select the face, edge or a point, but right now I would like to go ahead with the face. Okay, you can even select the edge also, but right now in the interest of the simulation, the face is required for me to run the simulation. Let's consider that. Yeah, so now the face is selected. If I just simply click on green check, so on this face all the degrees of freedom will be 0. This is completely fixed, a kind of welded thing. Okay, well, so once I apply the fixtures, next thing you could see the fixture here, it is available. If you want to edit this one, you can go here and you can even delete this or suppress this. Okay, these are all the options available here. Next, the load application. There are a lot of loading options are available. The force is there, and then the torque, the pressure. Okay, you can even apply the gravity, centrifugal force. Okay, a lot of options available. So currently I would like to go ahead with the normal simple force. Okay, so it will give again the tab for you. You can select the face, edge or a point. So this time again I would like to select the face. You can even see the direction it is showing, right? I'd like to reverse the direction, so for that you can use this option, reverse the direction. You can apply the value here. Let's assume we'll consider it as 500 Newton, or let's assume it is 5000 Newton. In short, it is 500 kg. Okay, if you want to convert kg into Newton, 9.81, you just need to multiply for the kg value, then you'll get the Newton. Okay, well, so per side it is there, no issues. So I'll proceed with this one. I'll simply click on OK. Okay, so this is how I have just applied the force on this. If you want to change the values, you can simply right click and go to the definition. You can make the changes there. Well, so once you are done with these, the next step is you need to apply the mesh. Okay, this is how the SolidWorks user interface is given. So you can just follow the step-by-step process, or if you want to do the mesh first and you can even do these all things later also, that is also fine, no issues with that. Okay, let's do this one. So right click on this, so you have most of the options. Okay, simulation advisor, simplify the model for meshing. So currently we've already done it. If you want, you can use this tab and it will automatically simplify for you. Let's consider create mesh. If you click on this, it will give you the option. You can set it to coarse, you can set it to fine, you can even reset it to center, or else if you want to define the value, you can do that. Here you could see there are different options. One is a standard mesh, and one is the curvature based mesh, one is blended curvature based mesh. Okay, so let's see what exactly the standard mesh is going to do. Okay, assume I would like to apply the 5 mm mesh on this model. Okay, and let's consider Jacobian points of 16. That's fine for me. I'll simply click on OK. Okay, so automatically the model is meshed. You could see everywhere constant mesh, and it is the everywhere it is. If you consider triads are there, okay, and tetrahedral mesh is applied. Now if you want to check for the mesh palette, you can do it here. If you want to edit this definition, what you can do is again can change the aspect ratio. If you want to change the display, it is just showing with respect to display. Okay, 16, let's say aspect ratio. If I just click on it, it shows the aspect ratio, so how the model is defined. So it looks fine for us. There's no issues with this. Okay, now I would like to again change the mesh. Instead of the standard, I would like to select the curvature based, and I would like to again select the value here 5, and you could see here we have the element growth ratio. I would like to keep it as 1.2 as a standard, and number of elements in a circle is 8. Fine, no issues. So let's click on green check. So now this time you could see you can even hide this and just double click on this to show the mesh. With respect to mesh, green check. Let's see, this is, it's not that fine but quite okay. Now let's see how exactly the blended curvature based mesh is going to give the result. So this time I would like to change it to let's keep it fine, and let's see what it is going to do. Yeah, you could see it is trying to blend everything, and at the curvature it is trying to give you the proper kind of a blend. Okay, so now this looks fine. If you want to again remesh this, you can do that. Let's assume what I'll do is I'll just try to set it to 3 mm, and I would like to just mesh it with the blended curvature based mesh, and this is how it is. This looks fine, but it is too fine mesh, but let's fine, no issues. You could see at the curvatures it has already given the what we could see, the washer kind of structure, so it is perfectly what we need for the mesh. Okay, this algorithm is best for us at the moment. Okay, blended one. So if you want to run the analysis, I would recommend you to use the default one. Yeah, now I'm done with each and everything. So what I'll do is I'll just run this simulation. So for that you can even right click here and run the one option, or else you can use this run the study option here. Okay, both are valid. So it will take some time with respect to the system configurations, whatever you are having it. Accordingly it will try to give you the results. Okay, now you could see the analysis results, right? So let me just switch to displacement. The displacement is 0.8, and this is the stress results. How exactly you could see, and these regions it is stress concentration is quite high, right? Now simple question, let me just change this setting here, fringe options, definition. So here instead of this two, I'll go ahead with the megapascal values. Okay, and displacement is automatic. Let's keep it as it is. Okay, and show the maximum annotation where it is there, and then if you want in the settings you can even use the discrete values, and this is how it shows. Okay, I'll simply now you could see it is, let me just click on green check, it shows in megapascal. Okay, it is just 27 megapascal. Actually the yield strength is 620. In the sense your model is not going to fail, right? Now let me do one thing. I'll just customize this give me a minute. Yeah, instead of scientific, let me just keep it general, and I would like to consider 4 digits and green check. Now you can easily identify how much is the stress on the model. Now by seeing this model, again the animation is quite weird. If you want you can even change it, go to edit settings again. So what you can do is you can just set to true scale so that it won't even deviate much. You could see this is the spot where we have the higher stress values, and then how do we now consider whether it is failing or not. So you can even do the factor of safety plot. You can even select this one, and then it will try to plot the factor of safety for you. Okay, multiplication factor is 1, factor of safety distribution is fine, so click on 0. So now you could see, so your model is completely safe. The factor of safety is 23. should be greater than 1. So now how come we can predict the failure? So what I will do now is, so I'll try to change this value now. Instead of 5000 Newton, I'll go ahead with the 50,000 Newton. Okay. Now simply click on green check. You could see it is 23 in the sense I think I can let's see. Now I have changed it to 50,000 Newton. I'll rerun this model, okay, with the increased load. Now we have the result. Now still you could see we have 620 megapascal for the yield strength. We have the 270 megapascal as a maximum stress here. Okay, factor of safety, if you go here, still it is 2.3. Still your model is safe for the given load case. Let's assume we'll again double it. Okay, just double click on this and make this to 1 lakh. Okay, it's not the case. 3, yes, let's see now. Now again I'll run this. This time let's see what exactly is going to happen for this model. Now could see it is 620 and my maximum 1 mesh stress here it is 540 megapascal, and if I go to factor of safety, still it is 1.1, still safe enough. Okay, in short, this particular design is quite good for whatever the application you're looking for. Now for the same load case, let's make some modifications. So what we'll do now is, okay, just go back to your sketch here, edit this one. We'll do some design modification. Instead of this circle, I would like to create an ellipse. Let's see. Okay, what we'll do is we'll try to just have it like this, and this is what I would like to have it. Green check, and if you want you can even define the dimension for this. Let me just rebuild it first, Control P, and switch the model here. This is what it is. Okay, model is changed. Let me define the dimension for this. From here to here it is 20. Now I'm trying to give the sharp curvature. With this, let us see how the model is going to perform with the same load case. If I have the circle, the model was performing good. I'm having a good factor of safety and everything was fine. Still it is underdefined, so I need to make this horizontal. Okay, now the model is fine. Let's switch to the static here, and now again I just need to remesh and rerun. Let's see, directly rerun this. So now you could see with this design change, my yield strength is 620 and the stress is shooted up to 1243. Definitely it should fail, right? Factor of safety reduced to 0.5. In short, you could see the displacement also, it is 0.19, but that doesn't matter here. The strain, plastic strain is again 0.004% plastic strain is there. These are the critical hotspots you need to work on, but I could easily see the stress results and I could identify where exactly my model is getting failed. These are the regions, right? Now I hope you understood, right? So how you make your design, so what and all the things you need to consider in short to make the analysis better. Now see, by just changing the circular shape to elliptical shape, the stress hotspots has been drastically increased. The model was performing better, but just a simple design change made my design worse and it is completely failing. So this kind of analysis only you need to do, and you need to tell your counterparts or the vendors. You need to check everything and then you need to tell them this is what is happening. You can even use this option. There is stress hotspot predictor. Let me just see where it is. Factor of safety, stress strain, yeah, stress hotspot diagnostics. Let's click on green check. Let me see again. Diagnostics. No stress hotspots detected. So this model is fine. Due to this radius of curvature, this is an issue. What is stress hotspot? In the sense, if we have the infinite stress due to a local region, let's say you have applied a fillet and that fillet is not that sufficient to distribute the stress, in that case you might get the stress hotspots. Let's assume that scenario also in this case. So what I will do is here on this face, let me switch to the model. Let's create a sketch so you can even understand what is stress hotspot, and this is very important for each and everyone to know about the stress hotspot, why it is important, and what exactly we need to do to avoid that. Okay, so this is the sketch. I'll make it as 5, and from here to here let's assume the dimension is to 85. Okay, and this total distance I'll apply 25. Still it is underdefined. What might be the reason? So it is moving up and down, so it is not exactly horizontal to the origin, so I'll make it horizontal. Exit. The sketch is ready. I would like to just extend it up to a certain distance, assume it is 20. Okay, so from this okay, let's assume like to split it here. Okay, that is important again. So what you can do is you can just sketch here. I would like to apply the load only on this particular region. Okay, let me just define the distance from here to here. Take it as 5. Exit. Now I would like to apply the load on this face, but not on the whole face, only on this. So for that I need to split this face. So you can use a split tool. Just search for the split line, meshes, projection, sketch is selected already. This is the face. Just click on green check and you could see the model, this face got split, right? We have 2 faces now. Let's do one thing, just switch back again here. Now I'd like to again apply the force. So the same force, let's do one thing. We'll apply another force on this face. It should be reversed, and force should be 85,000. Let's assume this. Okay, green check, and now I'll just simply run this analysis. Let's see. Okay, and this is what you have it. Excessive, okay, no issues. So I'm not going to run the large displacement. In the sense, for this force the model is going beyond the plastic strain region, and it is showing me the more displacement out at this region. So now it is not expanding, it is also trying to bend towards this, you could see now. And now you could see the stress, it is too much, isn't it? So now let's see now. If I try to predict the stress hotspot, it should show me this time. Yes, you could see it is showing the stress hotspot detected. Click help to more about this stress hotspot. If I do this, so it is going to take me to the stress hotspot. I don't want to have this, so click OK. So you could see these are the regions, so where we have the high stress hotspot. Now how do we avoid this? You need to remember, I would like to explain more about the stress hotspot. In short, what exactly the stress hotspot is. Stress hotspot will arrive if you have the model where the stress distribution doesn't have the appropriate area to distribute the stress. Here you could see at this region we have the sharp edge. So the force will be applied. Okay, here it will be a lot of force applied. So to have the distribution of that particular force, we don't have the area itself. So force per unit area becomes infinite and stress will shoot up drastically. So now how do we avoid the stress hotspots? For that, what you can do is again switch back to the model, just select this edge, apply the fillet. Let's assume here also would like to have, and here also, and here too, and here I might have the sharp edges. So let me do one thing, I'll apply the fillet here also, all the four corners. Now let's see. Okay, now what I have done is, to avoid that stress hotspots, I have artificially created some of the fillets so that I could have the proper area to distribute or to make the flow of that stresses on the model. So let's see, if you're applying the force here, it is trying to bend here. The stress due to the compression, the stress is relatively more, so that should be transferred on this particular plate. This is what I'm trying to do now. Let's assume this solution might work and try to rerun this. Let's see how exactly this is going to help. So this time again it is showing me that this model is going for the excessive displacement. It should happen because, yeah, now still I could see the force is distributed, but the stress is again more, right? The stress hotspot, if I could again check for this, I'll just delete this, and if I again check for the stress hotspot and click on the check, still I have some. Now in short, this particular fringe and 85,000 Newton force is too much. Let's just reduce it to 50,000 and try to run this. I just want to avoid that stress hotspot in short, so I'm trying to make the modifications in the model. Actually, design changes I should do. I should not reduce the value. Now I could see still this particular frame is not considering this particular load case. If I just even switch to factor of safety, it is 0.072. In the sense it is drastically failing. Okay, and these are the location where it is going to have the crack propagation or whatever it is. So actually it should be here. Now, so what we could do for this is better just reduce the value of it now, just to make this analysis run. So let me just take it as 15,000. Assume this is the preferable value, and let us hope this is going to help out to reduce that stress hotspot and give us the result. Yeah, but still I have the stress hotspot. In short, this particular frame is not capable of withstanding this load. Okay, now in short, I would like to keep the same load paths, and I would like to make the design capable of holding this particular result. So I think the direction I should change. Let me just change it to reverse direction and rerun it. Let us see. I don't think it is going to pass. So now what we can do, so let's assume we need to make some changes. So still it is failing. Okay, now what I can propose a solution is, first and foremost thing is, I would like to increase the cross section of this. Instead of 5 to make it 10, double of it, and this I would like to increase it to 50. It's too much, but let me just take it as 45. Now this should help me, and continue. There is some issues with the split line. Okay, redo this, edit this one. Okay, the sketch is not complete, so what I can do is I can just edit the sketch and simply drag it outwards so that it should properly split the face. This is perfect, right? And now I would like to also change the shape, because somewhere I feel this is not going to work. So let's do one thing, increase this to 40, and let's see, I have made 2 changes, so this should work, and slightly increase the thickness of it. So instead of 10, I would like to make it as 20, or not 20, it is too much, so let's make it as 15. Okay, So these are the possible design changes I have done it. Now let's see how our model is going to work based on these design changes. You could see still I have this stress hotspot, but it is this not the stress hotspot. This is because of the movement of this model. We don't have any stresses here. The modification was perfect here, but I'm having a lot of stress here. How do we avoid this? If you want to see the animation, so what you can do is you can just play for the animation. Let's say I'll switch to the displacement and right click, and you can just play animate. So this is how it is trying to move. So it is moving 2.3 mm, so definitely it should fail. Okay, so what should I do now? So the best modification I could do here is to remove this one. So just make it for construction so that the issue should be solved. Okay, I don't have that hole itself now. With this change, if I run this model, there should not be any issues, but yeah, you could see your model is perfect, and the maximum stress I could see it is 581 and 620 is my yield strength. If I switch to the factor of safety, it is 1.1. My model is completely fine, and these are the failure regions I need to improvise, and you could see the stress, and even if you want to see the strain, so these are the regions where the plastic strain is going to happen. Okay, so in short, this is how you need to work on the simple structural analysis. Okay, so this is very important for each and everyone. So I hope you got to know, right? So what is stress hotspot, what exactly the stress is, so how exactly we need to make the design modification. So very important. So these all things will help you out to run the simple stress analysis and make the decision out of your own. You can even suggest to counterparts or a BTV or your project owner that this is failing and these are the possible changes we could apply, and try to make sure this model is going to work. In short, let's say if you want to reduce this stress hotspot, what is the best possible solution for this? I would recommend to have the fillet here, right? But again, there might be some disadvantages with respect to the machining and applying that one. So again, the manufacturing cost might increase, but you can propose a solution to the counterparts. So if they are okay with that, they will proceed, or else they will tell you to remove the complete hole, not necessary. Yeah, or else you can even do the topology optimization on this one. So let's assume the model weight, if you want, you can check here, you can go to the mass properties and it is showing 231 grams. So if they want to make it 150 grams, and it should also meet this all the requirements, so in that case you can just do the optimization and try to reduce the mass and also improve the performance. Okay, that is again a vast topic, guys, so don't need to worry about it. Yeah, so just to summarize, in the session I had taken you through the basic structural analysis using the SolidWorks user interface, and how we can set our fringe bars, and how we need to run the simulation, how we can set the boundary conditions, material application, what kind of measures we have and how we need to use them, and the factor of safety. So everything is working fine. So this is how you need to run the normal structural analysis. If you want to run the frequency analysis also, you can do it. So this is the model. I'll just switch back to the frame, and now this is the tuning fork. Usually it should be means the natural frequency of the tuning fork is 420 to 480. It should lie in that, but this design is quite different, and I don't know what is the natural frequency or resonant frequency of this. Let's find it out. Okay, so what you can do is, I can directly again switch to the simulation, new study. This time I'd like to do the frequency analysis. Just click on green check, and the first direct thing is the mesh. I would like to mesh it. Create mesh. This time it is in inches. Switch to, okay, I'll switch to mm. Important for me. The mesh is too fine here. Let me just take it as 3 mm, and create mesh. Okay. Just taking much time in the sense this mesh is distorted. No. Okay, it is not taking, so let me just apply the material first. Let us take it as plain carbon steel. Okay, and now let us do one thing. Mesh controls. I'd like to remove this, and then I would like to recreate the mesh. Before that, let me set the unit system to mmgs here at the bottom and select the create mesh. The mesh parameters, blended curvature 3. Okay, let's hit on green check. If your system is good one, so you can even try to mesh this model within few minutes. And you could see this is how the mesh is being generated, and due to this one, can you see these all were unnecessary. What we can quickly do is, so we would like to suppress these features which is completely not necessary for us, right, which will help us to just fix this, the mesh issue, because it was taking a lot of time, right, to mesh this only. So here one fillet is there, this is the wrap, this is needed, this up to here is not needed. I'll suppress these. Sorry, I might need this mesh here. Yeah, this can unsuppress. This is perfectly fine. I can switch back here, and if I simply right click again and create mesh, it should not take much time. Yeah, it is done, but still I have this one. But at the moment, no issues. I can proceed with this. So still I could remesh this, but it is necessary to make the model cleaning properly. So let us do that. These two gone, so I think it should work. Now instead of 3 mm mesh, better we'll try to reduce the mesh size slightly to 2 mm, and this time curvature based. Let us see. I'd like to take the growth ratio 1.2 is the standard. Green check. This looks fine. If you want, you can still refine it. I would like to refine it. Make it 1. Let's try the blended curvature with 1. Yeah, this looks fine. Perfect, right? Good. So now the model is ready. If you want, you can even apply the fixture. Instead of, if you don't apply the fixture, what it will do, we'll see that also. Let me just run this analysis. So if I do that, it will try to run the frequency analysis on the model, and it has given you the mode. So 1, 2, 3, 4, 5. If you consider all the 6 degrees of freedom will be 0, because I haven't fixed this model. So you might have known about the degrees of freedom, right? There will be 6 degrees of freedom: translation and rotation. 3 translation, 3 rotation. So I need to have more modes. So how we can define that here is, so let me just see for that. If I just go to properties, yeah, number of frequencies, I might need to extract up to 10 modes. So let me just click on OK this time, and I'll rerun this. So this time it should give me, instead of 5 modes, I should have 10 modes. Okay. The problem is unstable and increasing the variation. Okay, no issues. Failed. Okay, let me see what went wrong here. We switch to 6 and okay. Let me rerun this. This should not happen. The problem with numerical unstable. Okay. What should be the reason for this? Okay. properties and upper frequency bound, let me just keep it as 1000 Hertz. Not 1000 is too much, let me just keep it as 800 Hertz. And yeah, click OK. This time it should work. Let me just remesh it with 2. Okay, so these are the results. I would like to delete them first. Let us see now. Run this. Calculation of frequencies up to an upper limit is only available in the iterative solver. Okay, there's something wrong. I will try to use the Intel Direct Fast Solver. This shouldn't happen, but it is happening. Increasing the problem with the negotiable. Turning on the shift flag, increase the value of the shift may help. Okay, let's do one thing. Let me just delete this one and rerun this simulation frequency analysis. Click OK, and let me just directly define the properties here. I would like to number of frequencies, I would like to take it 7. Click OK. I would like to run directly with the default. Okay, I need to assign the material, so plain carbon steel. Let's run this. Yeah, this is fine. You could see 1 2 3 4 5 6 7. There might be a bug, I believe. No issues. So now, as I said, if you don't fix the model, very important guys, the first 6 degrees of freedom or the first 6 mode shapes will be with 0 Hertz. You could see the first one and the second one. If you want to see the animation also, it is clear for you. I'll just try to animate this. You could see this is how it is trying to move, right? And then you can switch to second one. It will move along the again different direction. Likewise, you could see the value, frequency value also. It is 0 Hertz, still 0 Hertz. Fifth also 0. Sixth is also 0. And if you want to see the animation of the sixth one, you could see it is moving again like this. And the next one after that is exactly the natural frequency of the model. Okay, you could see this is how it is going to behave. And if you want to test this one practically, this is how it is going to behave, right? So I hope you people have already done this particular analysis. Just hit the tuning fork and try to use the resonant frequency, and you might even noted that what is the natural frequency or resonant frequency of that particular tuning fork. So it should lie from 400 to 480 or whatever it is. So for this particular model, it is 414.63 is in natural frequency of this particular model. Okay, so what is the advantage of doing the model analysis? So very important thing is the first thing, whether your model assembly, if you have it, if it is going to properly assembled or not, you can check it there. And the second thing is you can check the resonant frequency of the model, so that if the other components are meeting the same resonant frequency, definitely catalytic failure will happen. But if some components might work with the resonant frequency also, that you need to keep in mind and try to check the model. Okay, main thing of this model analysis is to check the assembly of this one and find out the resonant frequency and also the mode shape, how the component is behaving with respect to the stresses. If you have the stresses, there are a lot of model analysis with the pre-stress included and the fixtures with also the load application. So there are a lot of applications that are available, but in this session this is what we have covered. I hope it is clear for each and everyone. So how we can run the basic structural analysis and the model analysis to predict the basic mechanism of it and the resonant frequency and the mode shape of it. And in the basic structural analysis, we had gone through all the basic steps to cover the structural analysis and meshing and the material application, and also the design changes required and the stress hotspot and factor of safety also, and how we need to improvise and optimize the model. Yep, I think that's all about this session, and I hope you people got to know something up from this session, and we'll come up with the again advanced session in the next particular webinar, the third webinar on the simulation. Well, that's all about this session, guys. See you in the next webinar. Until then, bye everyone.